In this lesson we're going to solve logarithmic equations, only this time we're going to have a logarithmic expression on each side, and we'll use the one-to-one property of logs. And that property states that if the log of base b of m equals the log base b of n, then m equals n. So basically, if the bases are the same, you can just set the arguments equal to each other. And so what's going to happen is, once you learn this new method, it's going to be important to be able to distinguish when should you use one method as opposed to the other. And basically, if you've got a logarithmic expression and you have a constant, you're going to try and isolate and get that constant by itself and use the definition of a log. If you have logs on both sides of the equation, generally you're going to use this method. Alright, so the first thing we want to do is we need to get the equation in this form. So we're going to condense the left-hand side. So we have the log of x over 3x plus 1. I'm using the quotient rule. So the difference of two logs is a log of a quotient. That's equal to the log of 1 over x. Now I can set, this would be my m, and this would be my n. So I set x over 3x plus 1 equal to 1 over x. And in this case, you could, since this is a rational equation, you have to either use the cross products or multiply through by the LCD, which would be x times 3x plus 1. And now your 3x plus 1's cancel. You get x squared is equal to, the x's cancel here, 3x plus 1. So now we have a quadratic equation that's not factorable, and I would use the quadratic formula to solve this. So x would be equal to the opposite of b, which is 3, plus or minus the square root of b squared, which is 9, minus 4 times a times c, all over 2a, which is 2. And so there are two values that I'm going to get out of this. I like to simplify before I put in my calculator, so it's going to be 3 plus or minus the square root of, 9 plus 4, which is 13, over 2. Okay, now let's type this in our calculator to get our approximate answer. Let's round this to the nearest tenth. So I have, when I evaluate a fraction like this, I just evaluate the numerator, so 3 plus the square root of 13, and I hit enter. And then I divide by the denominator, which is 2. And so we're going to round to the nearest tenth, and I want to use that store feature again so we can check our answer with all those hexadecimal places. So I'm going to, since I have two values I'm going to store, I'm not going to use x, I'm going to store in alpha a. So you see that alpha button, that's the green button, those little green letters, okay, are also variables that you can use. I'm going to hit enter. So I know one of my values is 3.3. This is my rounded value, and I'll just put a little a up there so when I'm going to check it, I know what variable I stored it in. So now I'm going to evaluate 3 minus the square root of 13 over 2. I'm going to hit enter. I'm going to divide that by 2, hit enter, and then I'm going to store my answer in alpha b this time, and b is right above the apps key, and hit enter. I'll write that value down and remind myself that I stored it in b, so negative 0.3, or negative 0.3, and I stored that in b. Alright, so I know in order to I need to check these values, and I am allowed to check using my calculator, but right away I know that this negative 0.3 is not going to work, because when I put negative 0.3 in here or here, I'm going to end up with a negative argument. So I'm just going to cancel that. We omit that from our solution set. So I want to check the 3.3. So I'm going to pull up my calculator again. Checking the 3.3, we're going to type in log, L-O-G, And instead of writing 3.3, because that would give me my approximate answer, I'm going to hit alpha A. I'm going to close it. So basically I'm typing this equation in, typing one side of the equation in, and wherever I see an x I'm going to put that A. So minus the log, oops, I don't need that extra parenthesis, log of 3 alpha A plus 1. I'm going to close that and hit enter. I get negative 0.5188. Now I want to evaluate the right hand side and see if I get the exact same value. So I have the log of 1 divided by alpha A, close the parentheses and hit enter, and I get the same exact value. So now I'm convinced that, again, that 3.3 is a good solution.